So here is a cool trick that you can do to your friends, and I want you to figure out how this works. And let's start. So think of a positive integer, right? It should be positive, it should be integer. And B says, okay, so this is a conversation between two students, A and B. So B replies with okay. A says multiply it by 3 and divide it by 2. B says done. A says does it contain any decimals? B says yes. So when you multiply it by 3 and divide it by 2, it contains decimals. Okay. Now A says round the number down. In other words, remove the decimals. So B says okay. And now we remove the decimal, and then A says do the same thing you did before. Does it contain any decimals? So B says no. And by the same thing that you did, by this sentence, do the same thing that you did before. A is referring to multiplying by 3 and dividing it by 2. And then he also asks the same question. Does it contain any decimals? B says no. A says, what is the quotient as an integer when you divide it by 9? So B says it is 2. So let me give you an example what I mean by quotient as an integer. Let's think of 20, right? When you divide it by 9, you get 2 point something, right? And when you take the quotient as an integer, you are taking the 2. So that's basically what I meant. And B says it is 2. A says so you guess 10, and B replies yes. So A successfully manages to guess the number. Let's see how this works. Okay. So n is an element of the natural numbers. So we can express every number in this format. So I should have written every positive number, but whatever. So we have 4n, 4n plus 1, 4n plus 2, 4n plus 3, right? So for example, take 20, right? 20 divided by 4 is 5. So if we set n to be 5, so 5 multiplied by 4 equals to 20. So we can express it. Or let's take 19. 19 divided by 4 is 4.75, right? If we take n to be 4, right? 4 multiplied by 4 equals to 16. So we also need to add 3 to it. So we get 19. So we can also express 19 too. And basically, as I said, we can express every positive number in this format. And now, let's write down our steps. Now, we have step 1, multiply by 3 over 2, right? 3 divided by 2. Okay. Step 2, tell the other person whether there is a decimal and remove the decimal if there is. Step 3, multiply by 3 divided by 2 again. Step 4, same as the step 2. And then step 5, divide the number by 9 and tell the other person the quotient as an integer. So these are the basically steps to our trick. Now let's see step 1. Multiply by 3 divided by 2. Okay. So these are the numbers again. I wrote here 4n, 4n plus 1, 4n plus 2, 4n plus 3. As I said, we can express every number in this format. And what I'm gonna do it, since we can express every number in this format, let's actually use our steps. So let's just apply our steps to these numbers. So since we can express every number like this, when we apply our steps to those numbers, we should get some answer, right? So 4n. After the step 1, we get 6n, right? 4n divided by 4n multiplied by 3 divided by 2, we get 6n. So we do the same thing to this one too. 4n plus 1 multiply it by 3 divided by 2, you get 6n plus 3 divided by 2. And do the same thing, you get this. Do the same thing, you get this. So these are basically numbers that we get after applying this step 1. Now let's see the step 2. So we need to check the decimals, right? So in step 1, we multiplied it by 3 divided by 2. Step 2, we check for the decimals. So in here, we don't have any decimals because n is an integer, and 6 multiplied by an integer is also an integer. But in here, as I boxed it out, 6 multiplied by n is an integer. However, 3 divided by 2 is not an integer. So we round it down to 6n plus 1, right? And we also tell the other person that we got decimals in here. So in here, we don't have any decimals. So 6 multiplied by n is an integer. When we add 3 to it, it's still an integer. 6n plus 9 divided by 2 is not an integer. So we round it down to 6n plus 4. Also tell the other person that we got decimals. And in these two steps, this one and this one, we didn't get any decimal places. Let's continue. Let's apply step 3 to these numbers that we found. So 6n, apply the step 3, you get this. Apply the step 3 to this number, you get this. Apply the step 3 to these numbers, and you get these numbers. Okay. Now let's continue. Let's see the step 4. We check for the decimals, right? We get 6n, and after step 3 we get 9n. We don't have any decimals. Here we have decimals, so I boxed it out. Here again we have decimals, I boxed it out. Here we don't have any decimals. Okay, now we also converted those numbers to, we rounded down those numbers, and also told the other person that we got decimals in these two steps, in these two numbers. And so before moving to step 5, I want you to pay attention to something. So when we start with 4n, we never got any decimal places, right? When we started from the 4n plus 1, in both second and fourth step, we got decimal places. When we started with 4n plus 2, we only got decimal places in the fourth place. When we started with 4n plus 3, we only got decimal places in the second step. So taking this into consideration, we can actually make a table like this. So this is the constant table. So if we don't get any decimals in step 1 and step 2, our constant is 0. By constant, I mean these additions to the 4n. So there is actually invisible plus 0 in here. So we have 4n plus 0. Since we don't get any decimals in any steps, we add nothing to it. And I just realized I made some mistakes in here. This should be step 2 and this should be step 4. I made mistakes in here, but whatever, let's continue. So in here we have 4n plus 1. So we got decimals in both places, right? So if we have decimals in both steps, then our constant is 1. So we add 1 to our 4n. Similarly, we got decimals in first place, in the second step, and in fourth step we didn't get any decimals. So that means we are actually adding 2 to it, right? And then if we don't get any decimals in second step, if we get some decimals in the third step, we add 3 to it. So I'm gonna fix this table really quick. Okay, I fixed the table. Now let's continue. Now after doing the step 4, let's see the step 5. Divide by 9. So we have 9n plus 1, 9n plus 4, 9n plus 6. These are the numbers that we get after the fourth step. And when you divide it by 9 and take the quotient as an integer, you are going to get n from every number, right? Because when you divide this by 9, you get n. When you divide 9n plus 1, you are going to get n plus 1 over 9. And since 1 over 9 is less than 1, you are going to end up with getting n. Similarly, 9n plus 4. So when you divide 4 by 9, you are going to get a number that is less than 1. So we don't take that into account. We only take 9n divided by 9. We get n. And with this we get n. Oops. With this we get n from every step. Now let's continue. So this is basically the trick. So you take whatever left at the end and multiply it by 4. And take the constant from the constant table and add it to 4. So this is basically the trick. Example. So take your number to be 63. So 4n plus some constant equals to 63. N equals to 15. C equals to 3, right? Yeah. Now, let's apply our steps. Step 1. 63 multiplied by 3 divided by 2. 94.5. Step 2. 94. So we got a decimal in here, and we tell other person about it. Okay, then after this step, we move to step 3. Step 3, we do the same thing as in the step 1. We get 141. Step 4, we don't get any decimal, so we just say we don't got any decimal. Step 5, divided by 9, we get 15.666. But since we take the quotient as an integer, we are gonna take 15 from here. And then let's review our table. So we got decimal from the step 2. We didn't get any decimal from step 4. So our constant is 3. Now we determined our constant, right? Constant will be 3. We determined our n. N is 15. So we add those two up. 15 multiplied by 4 is 60. Add 3 to it, 63. So this is basically a cool trick that you can do to your friends. And I got this problem from the Ross number theory. And this was the 2024 question. They asked this question. Since this question is not valid, I asked them if I can publish this in my YouTube channel. They said no problem, and just publish it. So that's it for this video. If you have any question, please leave a comment. Have a great day.